Check, check. Check, check. Hey, hey. Check, check. Hey, hey, hey.
Check, check, check. Check, check. Test, test, test.
Okay, sounds good.
Our presenter, Nathan Moore, is going to explain to us about a cache network. So let's welcome Nathan to the stage. Thank you.
Thank you, everyone. I appreciate it. I know we have a little bit of a small crowd today. That's actually a good thing, in my opinion, because it means if there are any questions, we'll actually be able to get to them, and we'll be able to talk about them. This isn't going to take too long. Again, smaller crowd, and I would rather optimize for everyone here rather than try to speak to a general audience which didn't show up. So let me start out with this particular project. This is, oh yeah, I should start with the usual disclaimer. Every corporation makes you put something like this in. PennyMac is no exception. So this is, they're not related at all to this. This is really me doing it on my own time because I find the project really interesting. I find it a lot of fun, and it just matches really well with the way that I think about the world. So a cache network is named comes from the Sanskrit, the basis and essence of all things in the material world, the first elemental created. So this hopefully gives a little flavor as to what the original dev team was going after with this project, that it should be some sort of base layer, it should be the ether, it should be the air that we're all breathing together, it should be something that allows everything to come together, because that's what's the first element created. This is the basis on which we're going to build things. Whoops. Now, Akasha itself is a Apache License 2.0 open source project. It comes out of the crypto world, and as a result, it uses a governance structure very similar to a DAO, a decentralized autonomous organization, where the decisions are made by the token holders in a weighted voting system. So the number of Akash tokens you have determines the weight of your opinion and how the community ultimately evolves. So it's very much a community-driven product. And there's a very, very active Discord, roughly 24,000 people in it right now. So it has a very large number of users, very large number of active developers, a lot of commits into its repo. Like most of these things, there was an original creator who came up with the original idea and did the original work. This was provided by Overclock Labs, and they remain, of course, the largest contributor to the project. No horrible surprise, that's true of most of these kinds of projects. What Akasha is really trying to do is it's trying to solve a very, very big global coordination problem. It's really not meant for a local container problem. It assumes that that's solved. It assumes that it can take advantage of Kubernetes everywhere, but now you have a problem of federating the things together because you can have different clusters in different places and different providers, and everyone's going to run their own cluster. And now you have a coordination issue. If I want to run a container, I'm the guy who wants to run a container, where do I want it to actually run? Who's actually going to host it for me in this federated environment? So it looks something vaguely like this. Yes, I absolutely used Google's Nano Banana to create this slide, and so it's a little bit in the busy side, but it does demonstrate what I'm talking about, which is that we have someone who wants to run a container. They need some sort of middleware layer which allows them to actually go and deploy it somewhere, but not just in one location. You can pick and choose which location you want to be in. So you can have multiple providers. Why have multiple providers? Because different providers are going to charge different prices. They're going to have a different set of use cases that they like to support. They're going to have a different set of features, and you can and should be able to pick and choose amongst them as to which one is going to do the best job for you. So to make this happen, there's this entire decentralized compute marketplace. So the way that Akash chose to solve this problem was not in a centralized manner. There is no one authority which says, okay, you go here, you go there, you go there. Instead, it's a fully decentralized solution, which means we get a lot of the traditional benefits of decentralization. And we'll see some of that showing up in just a moment, where we care about things like trustlessness. We care about things like encryption everywhere. In flight, at rest, you name it. And we care very, very deeply about the ability to sign things so that we can trace back who did what. So we'll have a permanent ledger so we know exactly who signed up for which service, at what point, what did they pay, and what all these other commitments are represented. So those go into a permanent ledger. So it really takes advantage of a lot of the mechanics that a blockchain has to offer. And that's why it says in the middle, it's this compute marketplace, because how is it that the person who wants to run a container mediates with this person who wants to host that container? That's what this project is here to solve. All right, so I mentioned a little while ago that, or just a moment ago, about how we require trustlessness because we have to be sure that if I'm going to have a decentralized environment like this, how do I know that the provider is actually running the container that I want him to run? How do I know that the compute that I intend to have accomplished is actually being accomplished? And this is one of the reasons why we have to have a trustless environment. The moment you have made that commitment now needs to be cryptographically secured such that the provider has to follow through on the initial commitment. And this is one of the reasons why this is a natural state sitting on top of a blockchain where you have a permanent record to enforce this, which is auditable, and you can go back and validate and verify that what you thought was going to happen is indeed what actually happened. So the other thing that I wanted to bring up about the blockchain in particular is its permissionless nature. The idea here, in order to have a marketplace, is anybody can enter the market on either side. So we should not be discriminating against who is allowed to run something. It could be anyone, and it could be any number of anyone's, and at the same time, we don't want to discriminate on the provider side. Anyone should be able to participate with any class or quantity or number of equipment that they have. And this becomes really important because one of the things that this winds up solving is for how is it that I can take advantage of otherwise obsolete equipment? How can I better take advantage of the current structure? If I have even desktop class computer sitting around and running, and I'm not using it 24/7, and I want to make it available at some particular point, why should it not be doing? I'm paying the electricity for it either way. So why should it not be doing something which is of use? In other words, it's trying to find these additional layers of abstraction that it can apply to take better advantage of the equipment that's out there, as opposed to the equipment that we want to be out there. And there are a large number of practical cost-saving measures which wind up driving the cost to provide to host the stuff down, and therefore the cost to run the stuff down. And this is one of the secrets, this is why this becomes so incredibly interesting, is because if we have this middleware layer which is between the providers as well as the people who want to actually, the compute customers, we were not dependent upon a centralized solution like AWS for this. So the vision starts to pull out from the chaotic world into the specific, and that what are we trying to do here is we want to be able to run this in permissionless environment. I do not want AWS to tell me, hey, you violated my terms of service because I just don't like the way you look. That can't happen here. That's the point of a permissionless environment. So some real quick marketing stats, because these kind of projects, people always ask, well, who actually uses it? And is there anybody who actually would use it, or is this just some sort of niche hobby? And the global application container market is actually fairly big. There's like $3.5 billion in revenue out there. So there are actually a large number of people who are willing to pay just to run a container, random container somewhere. It's growing rapidly, 27% year on year, which means that by 2035, they're going to expect about $39 billion worth of revenue for the space. Interestingly is the 75% versus 25% cloud versus on-prem. The vast majority of people who want to run a container want to run it in a cloud. They don't want to be the ones responsible for it. They don't want to self-host. They want to run it in the cloud. And once again, you see how this fits together with what the Akash vision is trying to allow you to do. A couple more factoids about it. Yes, it was started in 2015, Greg Osuri and Adam. Although mainnet didn't launch until 2020. This does use the Cosmos SDK, so that's the specific blockchain that it's sitting on. They basically are running their own blockchain, just it's built on top of the Cosmos. They brought in GPU support in 2023, and this will be one of the things we're going to see through here. My example is going to be about deploying OpenClaw on top of Akash. And that means, of course, you need some sort of AI solution backing that. One of the ones you can use is Akash ML. So you can actually use the Akash network itself, go ahead, run a container on somebody's GPU somewhere out in the cloud, and it's going to talk to your OpenClaw instance, also getting run on another container somewhere else across the distributed network, and they can all talk to each other, and it all works. And yes, there's a very active Discord, about 24,000 people in it, so it's a lively project. It's alive and well. Has this taken the world by storm? Well, no. So if you look at the actual network summary of what the project is, and the product is live, it works. We're going to see some examples of that. But when you start looking at, okay, well, fine. What's the total spent USD? We just talked about a $3.5 billion market. Well, Akash is responsible for maybe $5 million of that, so not very much. So this is both good news and bad news. This project is at its start. It's at its infancy. It's at the beginning. There's a lot of room to grow, and there's a lot of space here. But it's very much also, because it's small, there's an opportunity to jump in and actually make real substantive contributions to it. And like I said, it has a decentralized governance model, so it listens to its community in a way that most projects don't, because the community votes on what is going to happen and what isn't. And so all it takes is some level of ownership of AKT tokens, and congratulations, you get to vote and you get to determine very directly with real power what is going to happen with the project. And this is one of the things that makes it a little bit different. Okay, so when we look at like resources leased, there's 500 active leases currently on the platform. It's generating $2,000 per day, which isn't very much. Like I said, this is a relatively small. But if you look at network capacity, what does it say? It says that we have 8,200 virtual CPUs across all the various clusters that support it. There are 53 active providers, so there are 53 clusters that you can deploy your container to. And that these clusters cumulatively give you over almost 53 terabytes worth of memory and half a petabyte of storage. Okay, so how does this actually orchestrate everything together? How does it all come together? How does this marketplace actually work? Again, we are in a blockchain environment to handle our distribution. This is all decentralized. And so I'm going to start off on the left-hand side with the bid engine. So the bid engine works as a reverse auction. What's a reverse auction? A reverse auction is where in a normal auction you say you have one product which comes up for sale. Everybody bids. I'll give you $5, I'll give you $6, I'll give you $7. The highest price takes it. It ends. The gavel comes down. The auction is over. Well, the reverse auction is the reverse of that. Instead, someone comes up and says, hey, I want to buy one project. In this case, I want someone to host my container. All the providers now say, oh, I'll do it for $5. I'll do it for $4.50. I'll do it for $3. And then the person who wants to run their container picks from all the providers to say, hey, that's the one that I want. And for whatever reason, could be feature, could be price, could be any number of things. And then you provision out to their service and you proceed on. But the reverse auction is key. Now, in a blockchain context, how do we actually make this happen? And this comes down to the nature of a commitment, that when you have the word that Akash likes for the client is tenant, because they think it's like a tenant. You're renting somebody's server, and so therefore you're a tenant on the server. So they're using the word tenant instead of client. So you have to broadcast out the request. How does this work? This means I take my wallet. My wallet consists of a public-private key pair. Of course, you only make the public part available, and your wallet address is the public part of that public-private key pair, which means you can sign a transaction and verify that it was you because you sign it with your public key. So what do? You need to broadcast out your request, which means you're signing a transaction. Hey, I want someone to host my container. Here are my requirements list. You broadcast that out. You make the commitment onto the blockchain. The blockchain, what does it do? Well, it gossips amongst all of the validator nodes and broadcasts out your request to every single one of the validator nodes. The validator nodes see this, oh, I see this request. At the end of every block cycle time, a new block has to get created. What does that block created contain? Well, it contains your request. So your request is permanent. It's written in. It can't be changed. It is absolutely verifiable. You are who you say you are, because we know what the wallet address is. We have your public key. That you've made this particular promise, and that really was you, and that's what's written down to the blockchain. This is permanent. Now what do the providers do? The providers read in from this block, and they're scanning. So they pull every single new block, and they say, hey, a new request has come in from a tenant. What should I do about this? And then the providers have to say, well, yes, I can meet the requirements. I have a GPU or whatever the feature was necessary from that the tenant requested. And now I can actually go ahead and place a bid. Well, I'm willing to do this for $5 a month. I'm willing to do this for $10 a month. And then that gets sent back. How does it get sent back? That's another transaction to the blockchain. So you just write that commit. Once again, we know who they are because we've got the public address of the wallet. Everybody has their own unique wallet address. So when you do the response to the bid, you're putting your own, you're signing it with your own key. Therefore, we know the provider is who the provider says that they are, that they're not someone fake, they're not someone who's cheating, they're not someone in the middle who's going to say, sure, 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 I'm going to run your container, then not actually do it. It really is the person on the opposite side. Fine. So you make the commitment, and then all of a sudden, that gets written down to the blockchain. What happens? The blockchain goes, gossips with all the other validator nodes, everything gets written down, the block gets written, and then all of a sudden, the tenant now can select the bid, because all those bids just showed up in the next block. So all you have to do is read the next block. Oh, here are the responses to these. I know who I am, because once again, I have that public address. Everything was appropriately signed. I just worked backwards. Now I know how to match up what the tenant is going to be with the providers. I make my selection, execution starts, I submit my SDL script over, and everything spins up, and it all just magically works. But it lines on top of a blockchain semantics very, very well, and it works very, very well for a very large distributed environment, which dynamically allows people to add or remove themselves from it on either side. Specifically, yes, I was talking just a moment ago, a message create deployment, message create bid, message create lease, and these are our primitives, basically the properties that we need in order to actually make this whole thing happen. And this is how we just match between the buyer and the supplier. I should mention here that we did talk a moment ago how this is built off the Cosmos SDK, but it's set with a 6-second block time, which means that the time it's going to take elapse between when I want to get a provider and when I can actually get my container provisioned is 12 seconds, 2 blocks. First one, I have to write down I have to commit my first transaction. I want this. The second one, things come back, and bidders come back, I get to select it and move on. So 12 seconds. The nice thing about Cosmos, I'll just sort of throw this in the background, is Cosmos, because it implements Tendermint. Tendermint is the consensus protocol. After it goes and gossips, hey, this guy wants to make a commitment, how do you know that the block that you've chosen is hit finality? It's permanent, it's not going to change. That's referred to as finality, and Tendermint offers an instant finality. Another quick side note, we can go further if there's interest, is how it implements a Byzantine fault tolerance, which means it can tolerate, instead of being susceptible to a 51% attack, it's susceptible to a 67% attack. So it does improve a little bit on the quality, and this is one of the fun things that goes in. And it is a proof-of-stake network. The providers themselves can run validator nodes, because we talked about that. When you gossip, it's the validator nodes which are gossiping to each other, so you can absolutely run one as well and participate in keeping the network alive. And like any blockchain, you are rewarded if you have won the privilege of mining the next block, then you are paid out some level of tokens. So there is a very positive reason to run a validator node. You are paid to do that, and that fee ultimately comes from the value of the token that everyone has to pay in order to pay their rent so they can become a tenant on somebody's container host. All fits together. It all fits together. This is why it's so fun, because you can see the pieces of the puzzle, how they fit together. You can see how the concepts of what we're trying to accomplish with the container world lie on top of the blockchain world. It all fits together. This is why I like the project. It's a lot of fun. So yes, the formal timeline, we talked a little bit about this, how this works, where the commitment goes through with the timeline, and again, within 12 seconds, you finally hit to the fine completed contract. Blockchains, of course, even Cosmos will also implement smart contracts, and so you can actually have a formal, technically I guess it is a signed contract, because once again, it is signed with your encryption key. Again, I want to come back to the theme of everyone can participate. There really isn't a gatekeeper here. And this is super important when we start talking about when you are a provider, what resources do you have? And it winds up, there's a very, very wide variety of providers. Some guys are, yes, absolutely, they're running their desktop in their basement because it was on anyway, so you may as well do something useful with it, all the way up through guys running this stuff inside of actual data centers and various levels of professionalism. And so things like uptime become one of the components that you can compete on when you're talking with, when you're competing against other providers for the privilege of getting to host that container. All right. Another thing that lines up really well with the blockchain world, rent is due every single block. So every 6 seconds, you have to pay to keep your container running. Now, bear in mind, this is a tiny fraction of a penny, like 0.004 cents, like on that ballpark. So it's not like you have to pay $100 every 6 seconds. You're paying a tiny fraction of a penny. And so if you multiply that by the number of seconds in a month, you're going to get to a couple dollars a month, $5 a month, $6 a month, whatever, depending upon what the provider is willing to do. It is a market. The price will shift up and down, and the feature set will shift up and down based on what it is you're trying to do. But this does mean that settlement occurs on every block. So if you go to AWS and say, hey, host my container, fine, yes, they have services to do this of varying complexity and varying price points, and you can use their centralized service if you like. And they will bill you on a monthly basis, which means they can cut you off and hand you the bill, and congratulations, you're prepaying for the next month. So if you've ever played with especially some of the dynamic virtualization aspects of AWS, you know what I'm talking about, where you say, okay, this gets saturated, so spin up a new instance, that gets saturated, spin up another one, and then all of a sudden your monthly bill comes out to be 2 times, 3 times, 4 times what you thought it was going to be, and so that makes planning a little bit difficult. Whereas here, 6 seconds, that's all it takes. And you can spin up, spin down. But it leaves you with a much more flexible billing model. And as mentioned, canceling is trivial because that's just a commitment to the blockchain. Within 6 seconds, you're down. All right, so the next thing in here is the actual cluster service, the resource management, and this is what I suspect this room is going to be a little more interested in than the other aspects. Because you cannot prevent anyone from participating as a provider. That means your provider can have, there are some minimum requirement levels, so you might be getting those, or you might be getting something substantially better. Again, you get to, as part of the negotiation process, you're picking and choosing the provider based on what it is that they can provide. And so this is what, they have an incentive, the provider now has an incentive to make sure you are running on something better rather than worse. On the other hand, there's such a wide variety of price points that they can afford to price down. So the use of Akash winds up being substantially cheaper than pretty much anybody else because you're reusing otherwise unusable equipment in some cases, but the availability and the option is there to move up the hardware scale if that's what you want, and you're willing to pay for it. So there's a wide variety of availability here. So one of the things that I did for this is I looked at the minimum requirements, 8-core CPU, 16 gigs of memory, and I went ahead and deployed it on a server. I got my son's old gaming PC out, and that had, sure enough, 8 cores. It was Intel i7700, if I remember right. Had 16 gigs of memory. I had a NVMe SSD, so I used that. But otherwise, I was able to go ahead and deploy it and take advantage of it, even though this was running off of my home internet connection on a DHCP service. So I was able to set up just dynamic DNS, able to point my CNAME over from the permanent name that I was giving Akash over to my dynamic DNS name, and have everything continue working. And so even if the public IP changes, whatever, it's all going to percolate through and update. And of course, leased IPs, static IPs are something you can pay for with the professional hosters, and that becomes one of the things, if you're willing to pay for it, it is absolutely available. So they give multiple ways to deploy the thing. You can use an Ansible playbook. You can use KubeSpray. They have a provider console which tries to do the bulk of the work for you. The developers have spent a lot of time trying to make sure that this is easy to deploy. You do not need to be although it helps, to be an expert in Kubernetes in order to do this. So basically when I was doing this myself, what am I doing? I'm just running the Ansible playbook, I'm letting it install K3s, and I'm just kind of off to the races. It handles the bulk of this stuff for me. And sure, I have some games to play with my network, because obviously I want this computer isolated from the rest of the computers on the network, so fine, you can just play no shortage of games to do that. And this is all internal networking. You can get as complex and complicated as you like, or as simple as you prefer to be, depending upon what your own risk tolerance is and what your level of expertise is. But it's basically currently built off of Ubuntu 24 long-term support, and so nothing surprising there. The manifest service. We have an issue because once we've gone ahead, we've matched up buyer and seller, I want to go run this container, great. We've come to a price, we have an agreement, I've selected the right one. Now I have to say, what container do I want to run? And what specifically do I want to do about that? And this is what the manifest for. So you have a manifest file, which is what actually gets sent out to the provider, telling the provider what it is that the provider needs to do. And so Akash, to make this happen, defined their own stack definition language, SDL. It's just a YAML-based declarative language. There's nothing exotic about it. If you used YAML before, you recognize exactly how it's laid out. And now all you have to do is figure out what are the specific properties you're going to embed within this YAML file. And that's the only funky thing. But what are you really doing with it is you want the configuration. Do I need a static IP? Can I share a domain name? What is it that I want specifically for it? Resource requirements. So I have to tell it, well, yes, I do want a GPU, and not just any GPU. I want a very high-end. I want a H200. I don't want a consumer-level GPU, for instance. And various other deployment parameters. Okay, what container registry am I talking to? Where am I getting to it? So it's basically similar to a Docker Compose file, but there is a formal language, and they have a formal documentation with it. So the specific example I mentioned, deploying OpenClaw. So they have a nice standard one. You'll notice that the reason why I copied and pasted this part of the configuration file is there's that setup password equals change me to strong password. So that's always, it is a configuration file, and so you have the usual issues with configuration files where you don't want to embed your passwords in it, and you don't want to commit passwords, and you want the usual set of security issues around that. And we'll talk about that in a little bit more shortly. But that's why I brought this particular example up. Okay, so we have the manifest servers. We know we've got our people providing the service, and we know this is going to be run inside of Kubernetes, but Kubernetes has a set of operators in order to extend its functionality. And so Akash takes advantage of that, and there are multiple operators that get deployed to it. One of which is an inventory operator, because you have to report back to the service what is actually there. Because it's pretty important. If you're promising an end user, no, really, I have an 8-core CPU, you need that verification and validation coming back. And so there's an operator to enforce that. It also checks on the status of the GPU. So if you tell it, hey, I've got an RTX 4090, congratulations, you can now match that up against expected workloads or whatever your GPU winds up being. And so it validates and verifies and pushes that inventory out. There's also an IP operator. So we talked a minute ago about how by default, the minimum environment lets you run using dynamic DNS. So you can be in a non-static environment and still have this work because DNS is going to handle any IP change for you. So the worst case that happens is you have your TTL and your DNS record. That's the worst that's going to happen. And once that expires, it goes to the new one, and off you go. So just set a really short TTL, and you're not too shabby. You can actually make it work. However, if you want a static IP, you don't want to be in this particular world, and there are reasons to do that. You need an operator to make that happen. And that's what the IP operator is ultimately about. You also have a hostname operator that a lot of this stuff, as you full well know, especially if you're using something like an ingress controller, then all of a sudden it matters very much. You're going to steer traffic by what the inbound hostname is, and so you need to be able to set that and do custom hostname assignments and the like. So you need an operator for that, and that is provided. All right. So that's sort of the overall architecture. This is sort of how things fit together. We have an idea of what the stack definition language is like. We have an idea of what the manifest file. We have an idea of how you go about requesting a container. We have an idea about how you would go about actually hosting the thing. So let's go ahead and play a little bit more with some of the specialized workloads, some of the stuff that comes out inside of SDL. What does SDL ultimately allow you to do? One of the issues is that by default, a lot of your storage is ephemeral. So if you restart your container, too bad, too sad, it's all wiped out. You have to go get a fresh one. This, of course, if the provider supports it, you can supplement with a persistent storage. So there are options to do this if you as the provider have chosen to offer this up. And then, of course, it becomes part of the manifest, and this is one of the things that you report back. Your inventory operator pushes that back out to the Akash network so everybody knows, no, really, I have persistent storage and I can deploy that. So there's some internal stuff because the project is old enough now that it's gone through a couple generations of storage, hence you'll see this beta 1, beta 2, beta 3 nonsense. But really all it is referring to as new generations of storage technology come out and they are faster, and then you can specify which one it is, and now you can vary the price and vary your feature output when you are the provider making an offer, and you as the customer can pick and choose which one is most important to you if you need it. We talked a little about shared IPs. One of the fun things about shared IPs is that you can, if you're willing to use custom IP leases, you're willing to pay for a custom, that you're not just getting the static IP, but ultimately you're getting the ability to control port mapping. So now you can send whatever arbitrary port you like and map out whatever arbitrary port you like, and that is, once again, supported here. So you can specify out that if you have a, say, a non-HTTP-based service, not a problem. You can go ahead and let the network forward that as appropriate. Not everybody has a GPU that they are willing to output. Some people do, some people don't, and depending upon what the customer ultimately wants, of course, the provider can provide, and so you can match things. There are guys running on the Akash network who are running H200s. I don't think they've moved on to, I don't think anyone has any of the Blackwell stuff yet, but I'm sure that's coming down the line. So you have various points, and in your SDL you can actually specify which class of GPU hardware you want to run on, and that way you can specify what model you particularly want, and it tells you what the specs are and what sort of performance you can expect out of it. Yeah, the container registries, obviously any Docker-compatible container registry is supported, including if you want to run your own, by all means, run a private container registry or use any of the big public ones. It is up to you. And this just gets specified inside of the SDL language. The last thing I really wanted to talk about this is one of the key questions is, this is one of the potential weak spots, and this is one of the things where I'm not 100% on board with the rest of the developers on this, which is that right now, yes, you do need to use a secret manager. And you can use pretty much whatever you like, the AWS Secrets Manager, you name it. Obviously, support for that is in there because you're really just having to pass in what your appropriate token is in order to be able to access it. So you put this inside of your SDL, and that way you can put it in. But then you have this sort of recursive issue. I would really, really like environmental variables get set inside of SDL. So within your SDL file, you actually specify, okay, when this container comes up, use this environmental variable, use this for this, use that one for that. And if you're doing things like trying to put secrets in as an environmental variable, obviously it will work. But this is potentially a problem because if you have your SDL file versioned, congratulations, you're now committing your secrets into your repo. Very, very bad practice. And this is why I'm not pleased about this. But I agree with the point that you really can't prevent people from doing it if that's ultimately what they're choosing to do. So you have to acknowledge that the person writing the SDL script has a lot of decisions to make on their own. But I would absolutely urge everyone to take advantage of the secret management tools, and you'll be a lot happier. But like I said, this is one of those things I'm one of the few places where I disagree with the direction the project has taken. Okay, then if you want actual shell access, so great, I've gone ahead, I've deployed my container, I actually want to be able to go run something on it. You know, kubectl gives you all kinds of ways of executing internal commands and executing internal things. So either you put some sort of switch inside of your code somewhere that say, okay, if you get hit with this particular thing, return the state variable or what have you. Meaning even if you want to get to the point where what you want to do is run bash. You can still do that. It's a little bit funky here, so the specific way it's implemented, you have to know what your wallet address is, because now all of a sudden you actually have to go into the transaction logs in order to be able to track down specifically where your container is running and specifically how to get to it. And again, all these mappings are done within the blockchain itself, going back to that. And so that's why there's this deployment sequence number. So that's one thing that gets written down. This is why you have all these prerequisites in order to do that, because you actually have to be able to trace your way backwards through all the steps in order to get to the actual container itself. But you can. It just takes a little bit of work. All right, so we're going to go through one of the complaints about the project in the past, and this is a relatively new feature just within the last year, is, well, the project was built with DeFi in mind. It's meant as a decentralized protocol, so it's very much built using blockchain semantics and the way that blockchains work. But not everybody wants to do that. There are people out there who are using Amazon because it is Amazon, and all you do is give them a credit card, and off you go, and you're off to the races. So the question was, is it possible to implement a similar use case for the Akash project? And this is what just shipped last year, where it is possible. You can sign up for them, you can pay with a credit card. Well, what's going on behind the scenes? What's going on behind the scenes is, yes, you are paying into a, money gets swapped out of US dollars into the AKT token, which is what the underlying blockchain is expecting to get paid in. So that goes on behind the scenes. In front of the scenes, yes, all you've done is you've seen a transaction to your credit card for 20 bucks, 50 bucks, whatever it was that you agreed to, and then all of a sudden, from your perspective, you can treat it just like you would treat Amazon or Latitude or any of these other hosting providers who are doing functionally the same thing. Part of this, the dev team decided to include a bunch of free credits, so you're welcome to try those. There's a couple downsides to these. Yes, they do give you 100 bucks. The downside is they automatically halt your containers after 24 hours unless you convert to being an actual paid customer. But if you have AKT tokens, you can simply switch over and use those directly, and anything you start that's getting paid out of your AKT tokens, of course, runs permanently until you've chosen to stop it. So, fair warning about that. So this is really trivial. This is standard. You set up, click the Start Trial button, console.akash.network, easy. Once again, the focus from the dev's perspective was to make this as easy as possible to use, once again, because they're really trying to push adoption. It's hit that point where enough people use it, it's a real service, but not enough people have used it that it is a common service. So that's why I showed the figures from earlier talking about what the actual size of the Akash universe was like. And right now it's very small. All right, hence the need for the no crypto wallet. Once you go ahead and accept your free trial, great, you get the very default user interface here, where they tell you what your total cost is, how many deployments have you got, what your available balance is. There's links to documentation, and if you look in the left-hand column, you'll see templates and SDL builder. And so we talked about that. SDL is how we're building the manifest, so we can have custom manifest, and we can write whatever it is that we like. And when you write a manifest, that then becomes a template for what you're trying to do. And this is why we're going to go through and demonstrate what the specific template is for OpenClaw. Great. So I've gone through, I went into my template, selected the OpenClaw template, and what happens is all of a sudden, if you look on the left-hand side, you have to confirm that, are you sure you want to do this? And if you look at that, I want to point out the top line here, because embedded within that top line is a bunch of what looks like really random numbers, but what it's actually doing is it's showing off your wallet address. And this is how you can look backwards. Once you know what your wallet address is, you can look backwards and validate and verify, was this really me? And all of a sudden you know that it is. And this is why it's important to know what the underlying concept is, so this way it just doesn't show up and look like random number. At any rate, I go here, confirm my deployment creation, and then when I click continue, the right-hand side shows up, and all of a sudden, so we talked about the reverse auction. What happens? Everybody shows up who wants to go ahead and host this container. If you look at the top line above the dollar figures, you see, what is it that I'm requesting? Well, I need 3 CPUs, 6 gigs of memory, and 16 gigs worth of disk space in order to run OpenClaw. And so all the providers said, yes, I can do that. They've gone ahead and placed a bid. This $6.77 per month comes from a provider europlots.com. If you look up under region, it says HR. It turns out that's the country code of the Czech Republic. I did not know. I had to look that up. But if you don't want to host out of the Czech Republic, you could also host in Texas. That's the next guy down. And if you don't want to host in Texas, you can host in Michigan. And there are, of course, more providers here. There's well over 50 or 60 active on the platform. I just clipped out the top 3 just for space reasons. So you pick and choose who you want. You go ahead to success. It gives you a little bit of details about what happened and what the provision cycle actually looks like. And so it tells you that you were able to successfully do this. You have, I want to look at the top because I talked about how not just cost, but it says time left. That time left is driven by the fact that I have a $5 balance on this account. I chose to only give this one $5, $6.77 per month, so 5/6 of the way through the month, which is 23 days, is when this lease is going to expire. And that's hence the time left calculation. And it gave me my sequence number, so I know the sequence number, where in the blockchain it was. I know the transaction within the blockchain that commit occurred. So if I need to look backwards, I can find it. And it gives me the provisioning. So from the server side, OpenClaw had no problem. It was able to create a pod. It was able to deploy itself, bring itself up, waiting for a volume to be created. Then it creates it. It starts it. This guy's provider is having a little bit of difficulty because he says 0 out of 5 nodes are available. But then it wound up working anyway. So clearly one of the pods was just busy and it came back. And finally, it tells me that Ingress has been scheduled and it's been configured. Let's go to the next page if it will let me. There we go. So after that, I've selected the guy I want to host it. I just saw that the thing came up correctly, and then I get to this details page. So on the left-hand side is we have details. And once again, it gives the monetary details. It tells me specific features, what it's doing, what it's providing. And at the very bottom, it says URI. So that's the URI the whole thing deployed at. And I talked about this earlier about how this is ultimately getting controlled by DNS. So it gives me a very DNS-based URI. If you click on that URI, that's why I included the bar at the very top. Look, there's our OpenClaw instance. So the thing worked. It did what I asked it to do. It set it up. And remember, enter setup password. That's why I pointed out earlier when we looked to the SDL that it was actually set to change to a stronger password, and that's the password you would use right over there to continue setting up OpenClaw. Okay. So it is possible to use the thing without a crypto wallet, without a lot of DeFi knowledge. I acknowledge that DeFi can be very intimidating, it can be very complicated, it can be very confusing, and there's a lot to dislike about it. It has genuinely a terrible, terrible user experience. So that's why we spent the time first to go look at the easy way of doing it. What's the harder way? Well, the good news is that if you are familiar with a lot of the DeFi concepts, so bridging, for instance, and the on-ramps and the off-ramps to get into the DeFi world, then this is straightforward. If you don't, we're going to take a minute or two and step through that. Great. So window on the left, at the bottom, there's the switch to wallet payments, and it says, okay, well, great, which wallet? For this particular project, Kepler is a Cosmos native wallet, and so we'll go ahead and use Kepler, and we'll put that together. And what we're trying to do with Kepler, so yes, it requests a connection and it passes it in. The issue with Kepler is that first you have to go through the wallet creation process. What's the wallet creation process? This is where we determine what is that public and private key that you're going to use. Every address in the blockchain is your public encryption key, not your private, of course, but the public one. And that in order to regenerate your account, you are given a set of specific code words which need to be entered in order to regenerate your account, recover your account. So if you forget your password, that is literally your only way of getting that back. And this is one of the challenges of DeFi. You have no central authority to call up, I forgot my password, reset it for me, does not exist. If you've forgotten your key codes, then that's the only way you can get it back. So once you have your public address, then you actually have to fund it, and that is one of the very, very big challenges in the DeFi world, because to get tokens on the Akash network, Akash is running their own blockchain. It's different from everybody else's. Yes, it uses the same semantics as Cosmos because it's built off the Cosmos SDK. So how do you get money into and out of it? Is the first thing you have to do is you have to fund your wallet with the native coin of Cosmos, because it's a Cosmos chain, but then we're going to have to bridge it over to the Akash blockchain, because Akash runs a different blockchain, just same semantics because it's the same SDK. And in order to do that, you can take advantage of a DEX, a decentralized exchange. So you fund your wallet, you go to like a centralized exchange, Coinbase for instance, you buy Cosmos coin, which is Atom. You then have to go and bridge across from Atom over to the Akash blockchain. And in this particular case, I'm using Osmosis as a DEX, a decentralized exchange, to do that. You don't have to use a DEX. There are other ways of doing this. but this is probably the easiest way to do it. And once you have bridged the things over, then you can swap Atom on the Akash blockchain for AKT token on the Akash blockchain. And now all of a sudden we have the appropriate coin that we can use to pay for the gas fees, as well as pay for our utilization on top of the Akash blockchain. So you can withdraw your AKT back from Osmosis, because Osmosis was just the DEX, so you were just committing your tokens to there, and you can pull them back when you're done. So this is why I say, this is why the DeFi, it's not a very good user experience, unfortunately. It's the DeFi world, with the benefit of hindsight, the point of the DeFi world is to give you the primitives and the methods and the capability of refactoring the legacy financial system, and do so in a way which it disintermediates all the people you would otherwise have to pay in order to make this stuff happen. And that's the problem, is that in order to make that happen, we have all of the primitives, but now you have to be enough of a developer to understand how you put those primitives together in order to make what you want to have happen actually happen. Is it worth it? I would argue yes, and this is something that we already talked about, how a lot of these semantics get used internally, and so if you know what is going on, you can now trace stuff through, and you can better understand what the system is actually doing. And this is both a blessing and a curse. Okay, so I mentioned earlier that I went ahead, took my son's old gaming computer, and deployed it in order to become a provider. And it was very straightforward, very, very easy. You just install Ubuntu on it. Make sure you meet your minimum requirements, and we already showed minimum requirements. In this particular case, I just installed via Ansible Playbook, and I realized I had the console over there, so I had to take a picture of the display from the console as opposed to logging in remotely to it. So, but once you do that, it's all very straightforward. You let it install K3s, everything comes up, and you know, you're happy. At the end of the installation sequence, you wind up picking and choosing how you want to price. And there are some various provided pricing scripts to allow you to do this. So this way, this is what's monitoring the blockchain for new bids coming in. And if you want to respond with, customize your response to say, yes, I have this hardware, I don't have that hardware, I have this feature, I don't have that feature. And then this is how you would do it. You just write a little script to do it, and then everything is automatic. It happens on your behalf. And you can come back and revisit this if you want to change prices, if the model changes, if your costs change, what have you. All right. So that was a fair amount, but I do want to, this is a small group, so I want to make sure there's time here for any kind of questions that we can either jump in, so we can talk blockchain semantics, we can talk Akash network, we can go back and look at how the whole process works, we can do high level, low level, but it is absolutely open. Yes, sir.
Thank you. Sorry. In terms of security, how do you actually know that these providers are going to provide the service that you're paying them to provide?
Fantastic question. So we know from the, there's two ways to answer this. To answer this, I actually have to first talk a little bit more about the context of the blockchain is giving us. And so because we have the, every transaction is cryptographically secured. We mentioned the public-private key, everything gets signed. So the provider has made that commitment. I am going to do this. There's already an operator running inside of their Kubernetes environment, which has come back and is reporting, here's my state, here's what's running. So now you have a check. You have a way of validating and verifying that what it said it was going to do is what it's actually done. So you send over the manifest file at the end of the sequence, and then the provider's supposed to read the manifest file and then implement based off of that. And then you have to check.
Can I not just modify the operator to tell the system all is good?
If you try to modify the operator, you violate a checksum, and then that gets rejected by the system.
How? Like, it's my hardware. Is this using like trusted computing, or what's going on here?
It's not using trusted computing. What it's doing is it's taking its own checksum of the manifest file and it's reporting that back. So it has an existing operator to do that. I think, and please correct me if I'm wrong, is what you're asking is what if I try to short circuit that? Is that the question?
Yeah, basically, what if I just modify the entire system and make it report all is good here with the correct checksum and everything, because they can just do that?
I guess that's one of those things which is technically possible but practically impossible, where it becomes extraordinarily difficult to do that, because now you're stuck violating all of the contracts within the blockchain itself. So now you have to override. Well, it's not that easy. It's, to disagree very firmly with that. So you have to go through and, because now you have to violate the transaction that you've signed. And this is why I was going back to the sequence numbers, because as you trace the sequence numbers out, everything gets signed. And so therefore you have to know what the appropriate counterparty is signing. And that is, in my opinion, the real answer to your question, is that if you can violate that, then there is possible for a way to have the provider potentially cheat. The other way it could potentially cheat is if you are able to control over 2/3 of the validators on the network, because the validators are the ones that determine what the next block is. So in other words, I can override that address with a different address, and I can put in a different commitment. But in order to get the rest of the network to agree on that, I would have to violate the Byzantine fault tolerance in order to get that. So that's why I mean it is technically possible, but it's practically extraordinarily, extraordinarily difficult.
Okay, I have a couple of questions
Yes, sir.
involving workloads.
Okay.
So one of my questions is, so we're talking about, an experience where you're deploying containers that take a long time to deploy compared to, like, say, deploying them a GKE or something, but are relatively long-lived because you're talking about billing by the month. So what sorts of workloads do people run on the Akash network?
Great question. Yeah, there's a large number of, so the trivial answer is runners, but on top of that, there's a lot of guys who will use it for their own projects, and there are a lot of guys who will use it for more serious projects. So it sounds like a little bit of a waffling answer, because I'm trying to remember off the top of my head who the top 3 projects are. Oops. So there's a lot of guys, any kind of asynchronous workload is a really, really good choice. There are guys who are running, using it as the backbone to the OpenClaw, for instance. That was one of the things that I played with it. And there are a lot of guys who have used it for really toy use cases, like running Minecraft servers, anything which is, you can take advantage of not just the low cost, but also the fact that it's running pretty much anywhere.
Question involving workloads actually follows up on that question, right? Because you mentioned OpenClaw. And since OpenClaw was released, we've already seen some malicious uses of it.
Oh, yes.
And it feels like deploying OpenClaw to Akash network will make it even harder to figure out who owns a malicious OpenClaw instance than it would have been with, regular hosted serving.
Yes.
So what tools exist, if I represent an internet provider or law enforcement, and I am trying to shut down somebody running a malicious workload?
Yes. So you have to trace back through the sequence numbers within the blockchain itself to know which wallet did what. But the thing is, in order to use the service, you still have to go through a, you'll notice that, let me go back and show the providers. Let's go back. Where was that providers list? There we go. You notice the provider has a name? You have to register your name with the, oh, sorry, this shut off, didn't it? But you have to register your name along when you sign up as a provider in order to be allowed on the system. So because of the nature of the blockchain, you know exactly what load is running where on which provider. Because you know the provider name, you already know how to work your way backwards to, okay, I now have the name. That gives me the IP address, the host name, I have the website, I have the contact information of the person behind that particular provider. So I have a way to work my way backwards. Now the other half of your question is, okay, what if I have a bad OpenClaw instance running on my system? I am the provider, and I've just been told, hey, you have a OpenClaw system which has just done something. What do? Well, it's running local, so I just call kubectl. I know exactly what the name of it is because that's given back to me because I was able to trace through the blockchain. I knew exactly which one it was. So all I have to do is match it up, and I can even kill it by hand. That's the fun thing with rent being due on every single block is that I can cut things off every 6 seconds. So I can just say, I'm sorry, your thing has been terminated, and it's 6 seconds to do it.
I guess my question is a follow-up in some ways to that, as far as you wanted to kill an instance, but it was, as the provider, I should probably clarify that, you wanted to kill the instance early, before the tenant's time was had yet to expire, for whatever reason.
Yeah.
It could be a power outage. I know you would normally put a backup generator or something like that, so it wouldn't lose power. But what are the norms as far as like it being cut off too early, even in the event of a malicious attack?
Solid question. I think this hopefully helps answer the earlier question because, or what it was hinting at, because if you are the client, you have a fundamental issue that the host can cut off your service at any time for any reason. There is no guarantee that it's going to be up 24/7, 365. That's why they include the uptime numbers. See the uptime right over there? And they're letting you know this provider is only up 99.99% of the time, 98.08% of the time. And this is one of the things that you're ultimately bidding on. But this also goes back to the earlier question as well, okay, well, what loads do you want to run in this environment? And clearly, this is not going to be for something that, I'm not going to run IBM.com on top of this. Or if I do, it's going to be in some sort of exotic load balanced environment where I have multiple providers I can balance across. Sorry, my timeout's a little too short. And that is one of the challenges. I think that's one of the reasons why the product remains relatively small, is because my personal use cases for this are fun toy projects. I'm running OpenClaw inside of here. I'm running Minecraft. I'm running simple toy stuff where what I really care about is a combination of low cost and most of the time availability. I don't need 100% uptime. So this is actually a solid point. I probably should have included this in the talk, in that if what you want is the AWS 5.9 reliability, then, well, that is what you're paying the premium for. So I guess I probably should have brought that in. So from my perspective, this is a toy which is trying to become a real-world product, but it's not quite there yet. It's still just a little too small. It doesn't quite have everything locked down. You can see the vision, but it's not fully there yet. I hope that helped.
More questions? Okay, well, with that, thank you very much, Nathaniel.
Of course. Thank
for
you.
introducing us to a new and very different project. Thanks, everybody.
Awesome. Thank you.
And we now have a 1-hour break, followed by the final sessions in the program, and then followed by the closing keynote. So see you all in an hour.
Check, check. Check, 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 check.
again?
Yeah, mic check.
Okay.
Yeah, sounds good.
Good. It takes a second to connect.
Mic check. Yeah,
Yeah.
sounds good. Yeah,
Okay.
thank you.
Good afternoon. Welcome to the final time slot of the cloud native track at SCaLE, final session time slot of SCaLE. And in this final session, as you heard in the keynote this morning, there are more security and compliance requirements than ever. And our speaker is going to show you a way to enforce compliance in a location you might not have expected. So with that, let's welcome Sajal Nigam to the stage. Welcome.
Yep, thanks. Good afternoon, everyone. Thanks for joining me. My name is Sajal Nigam, and I work as a senior application engineer with Discover Financial Services, which is now a division of Capital One. And today I'm going to talk about one of the open source tools that I have created. I named it as Guard-On, which focuses on shifting Kubernetes compliance left with developer-first guardrails. Now, before I begin, I just wanted to make a disclaimer that this is completely done as an open source project by me, and it has nothing to do or does not represent the views of my company. With that, let's begin. So talking about first the problem statement, right? What problem are we trying to solve with this tool? So as you know, like Kubernetes misconfiguration slips through the reviews, and it triggers some kind of CI failures, or in worst case, it could be any kind of a production issues. So with that, there are tools which are already available, which are pretty good, and we are not trying to compete with that or trying to replace that. But if you look at all these excellent policy as code tools like Open Policy Agent or Kyverno, and there are many more, right? So despite of all these great tools, the misconfiguration remains one of the dominant cause of failure in cloud-native systems. So the question is, it's a question that really asked myself whether we need another policy engine to solve this problem. But I think the right question to ask is, are we enforcing these policies at the right moment in the developer workflow? So, and that's where the Guard-On is. And it's not a new policy engine, but it's a system that explores a new enforcement point. And that is running these policy as code at the review time. So in a nutshell, that is what the Guard-On is. It executes directly inside the pull request and entirely client-side without any CI and without any clusters, without requiring you any credentials. Now, let's take a look at what we already have, like what existing tools are already existing. And like at the earlier stage, we have these, actually I've divided that into 3 categories. Like the first one is your IDs, which is pretty much the local stuff that you do on your local machine. And that is the earlier stage. And that provides you a fast, interactive feedback while editing the manifest. So that is a great way. And all that for that, you need to install those tools on your local system. And then next we have the CLI command lines, which is again on your local machine. With the help of that, you can have some kind of a pre-commit hooks, which will again validate your configurations or changes that you're pushing in. But again, that is also on your local machine, and you might have to do some kind of an installation on your local machine, or in case you're using some kind of a command line interface, which connects to the cluster itself, that would need some credentials as well, right? And further downstream, like you see, there are the CI/CD integrated scanners, which where the policies are evaluated, and then it's actually after the code is pushed. So the CI scanners get triggered, and they do the policy review. And finally, we have those admission controls, which is pretty much a guardrail, and you can call it as a authoritative governance body, which would reject or approve your workload onto the system, onto the cluster. So, see, all these tools are valuable, and as I said, Guard-On does not intend to replace any of them. However, if you notice something important, each enforcement has some kind of a drawback, right? So the earlier tools are pretty much fast, but they are private. That means like only the developers who have installed would be able to see it, like the results when you run these. And then there are some late tools which are authoritative, like the admission controller and the CI scanners, right? These tools are authoritative, but they are too late. That means your code has already gone into the pipeline and you have already pushed those changes. So at that point, those CI scanners and the admission controller will give you the feedback, right? So I will call it a little late in that process. So what I can say is the IDs and the CLI tools surface violations only to the author, and reviewers don't see them, right? Whereas the CI and admission controllers surfaces the violations to everyone, but only the commit, only after the commits you see that in the pipeline or almost after the deployment has failed. So even the best-in-class tools, enforces it remains fragmented across time, context, and visibility. So that is why teams are often experiencing these policy enforcement as noisy, late, and frustrating. So even like when the rules themselves are correct, they exist technically, but they don't exist at the time of review. So this observation leads to a simple but underexplored questions. Like, what if we enforce these policies at the same moment the team already reviews and reason about the correctness of any configuration, right? So that brings me to the missing enforcement locus. So now let's take a step back and ask a very simple question. Right now, where do teams actually decide whether a Kubernetes changes is acceptable or not, right? It doesn't happen on your local machine using IDs. It doesn't have it in the CLI command line or maybe even after CI pipelines, right? Because it is after the fact. So the pull request review is mandatory, it's auditable, and it's collaborative, right? It's already existing, and it's where the developers, platform engineers, and security reviewers converge to reason about the correctness of any configuration. So you see that despite being the most important decision point in the SDLC phase, the policy as code remains, that enforcement is almost entirely invisible at this stage, at the review time. So reviewers sees the YAMLs, they see the difference, they see comments, and then they see the test results, but they rarely see any kind of a structured policy feedback at the time they're reviewing and in the context of what they're reviewing, right? So this creates a disconnect. The policies maybe technically exist, but they are enforced either privately, that is on your local machine using the command line interface, kind of a pre-hook. And the other part is if it is on the CI scanners or on the admission controllers, that is almost too late. So I see that the gap is not about the missing rules or the missing policies. It's basically about missing visibility at the moment of decision, right? And this observation motivates the central idea behind guard-on. So what if the policy validations happens inside the code review interface itself? At the same time, the reviewers are already examining the change, right? So that is going to make it interesting. Now, looking at the policy, the place the policy enforcement right now exists across the Kubernetes software delivery lifecycle. See, at the time of the development, the developers are using the ID linters. At the command time, they use the CLI tools, and then other pre-commit hooks as well, right? So at the integration time, they have these CI/CD scanners running, and at deploy time, you already have the admission controller. So each of these enforcement points exist for a reason, and none of them should be removed. And what Guard-on adds on top of it is an explicitly review time enforcement tier, which is between the commit and the CI, where the policies are evaluated in the same context as the human reviews. Now, by servicing these policy feedbacks here, we reduce the chances that the violations survive any kind of a review simply because they are invisible, right? So this also explains why Guard-on does not back any kind of it does not block any commits or any kind of merges. It just informs a decision rather than enforcing these. So the admission controller and CI pipelines still provide these hard guarantees because all those are authoritative and they act as a guard. So they don't allow you to push any kind of misconfiguration or compliance issues that can be caught there. So in other words, the Guard-on strengthens the governance without weakening existing enforcement guarantees. Now, at this point, some of you may be thinking about, why a browser extension, or is that really part of any SDLC phase? And it's a fair question to ask, and it's an important one. So the key insight is this. Basically, the SDLC is defined by the decision point on, and not where exactly the code is executed, right? So the pull request review is already formal, it's mandatory, and it's auditable. So that's part of the SDLC phase. So anything that influences the merge decision at this stage, that by definition is part of the SDLC. So we already rely on these browser-based delivery mechanism at the time of review, and code owners, reviewers, they check the inline comments and security alerts. All those already happen. So guard-on is simply adding a structured policy feedback at the same context. So you see, it's just about enforcing those policies at the time of review. So by running entirely client-side, guard-on eliminates infrastructure dependencies and avoids any kind of a CI scheduling delays, and prevent policy drift caused by per development installations, as I was explaining about any local installation that you have to do for running these policies locally, just in case. And every reviewer sees this same violations, which is very important, because when you're evaluating against the same policy, you should be able to see the same results. And without requiring any kind of a step beyond just installing a simple browser extension, right? For as an example, the local installations would need you to configure your all those installations. Plus, you might need some kind of maybe some kind of a credentials to log into and connect to your cluster. So equally important, this model actually preserves the privacy as well, which is very important. The configuration data never leaves the developer's machine, and there is no need for any cluster credentials, or any kind of secrets are involved in this, right? And once you accept this review time enforcement as a valid SDLC phase, the browser becomes a very natural place to implement it. So I'm just talking about the basic idea. By this time, you might have already realized what I'm talking about. But the guard-on is built on a very simple idea. And it's basically executing these policies directly inside the pull request interface at the review time, using the exact manifest the reviewers are reviewing. So that is the key, and you can say that is the whole or the core idea of guard-on. So when a pull request contains a Kubernetes YAML, guard-on extracts that YAML file, particularly that manifest file. It sees the different that there are validates, and then against any kind of a schema, it runs through the schema validation, and then finally the policies are executed, and all that surfaces those violations immediately. So this happens entirely the client side inside the reviewer's browser. So there is no cluster access, no CI pipelines, no external services, and no credentials involved. So you will see that when I'm going to do the demo, probably you'll be able to realize like what I'm talking about. Now again, the important point, the guard-on is not trying to be any kind of another policy as code engine. It does not invent any kind of a new policy engine or a language. It does not replace any of the existing tools, any admission controller, or any kind of CI scanners. So instead, it just introduces a new enforcement phase at the review time, right? That complements the existing tools. So you mean like all the organizations which are already existing these policy as code tools, it is going to leverage the same tools. So once you review the guard-on through that lens, maybe many design decisions, such as being a browser-based, a fully client-side becomes necessary rather than accidental. Now, I'll talk about on a very high level about the client-side architecture that it has. So, to make it a review time enforcement practical, guard-on is implemented as a fully client-side, a browser resident system. And at high level, it has 3 components, all of them running on the browser itself. So the first component is the content script, and this component integrates directly in the pull request interface, such as GitHub and GitLab. And it's responsible for extracting the Kubernetes YAML files in the PR differences and including any kind of a multi-document manifest as well. The second one is the background service worker, which is more of an orchestration layer, and it acts as a coordination layer. It manages these active rules, schemas, all the validation, the orchestration part of those validations without relying on any external services. And finally, the core is the core rules engine. Although I call it as a rules engine, but it is not a kind of another policy as code engine. It's basically where the schema validations and the policy execution happens. So the design is more or less a deterministic design where schema aware and the side effects it does not have any kind of a side effects. So all these components runs locally, and there is no server-side execution as of today. So whatever the version that I have released so far, it does not involve any kind of an external service or any kind of an external server setup. And I mean, particularly this architecture was chosen deliberately to eliminate any common source of latency, any configuration drift or privacy concerns, because any kind of a configuration leaving your system, that could be a concern as well, like for some of the industries. So because execution is local and isolated by the browser extension sandbox, Guard-on can deliver consistent, reproducible results with very low overhead. Now, easy policy reuse. So I was already talking about some of the existing tools which we are trying to leverage. So you will see that in the demo that how I am actually leveraging particularly Kyverno and the open policy agent as is. And the important point is this is one of the design decisions which I imposed on Guard-on deliberately, and it's because most of the organizations, they don't want to rewrite the policies, right? Most of the mature Kubernetes environments already have significant investment in the policy as code, particularly if you are using Kyverno or if you are using open policy agents Rego. So you don't want to do, rewrite these policies again just to have this a new tool introduced. So Guard-on is designed to reuse those existing policy assets and completely rely on them. So at its core, the Guard-on supports right now, as I said, like 3 policy sources right now. So first is the Guard-on native rules. So if you don't have those policy engines, you can pretty much write your native rules on your own. And the second one is Kyverno validation rules, which is kind of mostly used by Kubernetes native services. So it's basically it's a lightweight, and and then a lot of organizations are using open policy agents for a lot of reasons. So right now with this version, it supports both. So the point is that this means that organizations can take policy as is, like they don't have to rewrite it, and the policies that run on your any of your CI scanners or in your admission controllers, the same policy would be executed at the review time in your pull request. So what we are doing is bringing those same policies which would give you the same results maybe after the fact. The code has already been pushed into the pipeline, it's gone. That is going to bring all those reviews at the review time so that you can validate the correctness of those configurations. Now, this reuse model is also important for trust factor, and the review time enforcement only works if team believe in the results, and which is very important to establish that trust, that if I am able to see a particular result of a validation, then other person should also be able to see the same result for the same manifest, right? So that is the whole idea of establishing the trust, and that's what you will see here, why I'm calling it as a deterministic rule engine, and it is very important that you see a credible result, right? If the different reviewers see different violations, or if the results change between the runs, right, the system loses legitimacy. And for that reason, Guard-on's core rule engine is explicitly designed to be deterministic. So even the policy rules is modeled as a pure predicate evaluated against a single Kubernetes resource. There is no side effect, or no ordering dependencies on. There's no kind of an external dependency, external context is needed. So before any policy evaluation happens, each manifest is validated against a schema. It could be either the Kubernetes OPI open schema, or it could be custom resource definition. So that is pretty much common for any Kubernetes specific things, right? So all those can be loaded. So first step is that all the YAML would be validated against the schemas, and then finally the structured correctness. Once the structured correctness is ensured, then you go on to the semantic part of the checks. So you would see all that in the demo. and then the rules are evaluated independently, and they cannot be, they can be executed in parallel using the web browser workers. I'm making some use of WebAssembly as well for taking care of the open policy agents. And this design is it actually guarantees that given the manifest and the same policy set, Gardon will always produce an identical result. So that is very important, and that property matters not just from the performance perspective, but also from the governance and the reviewers, so that they can trust. Now, another important point over here I wanted to make is that the developer time to remediation, right? So latency is important, but what really matters is something much more, much simpler, is that how quickly a developer can actually fix a problem once they see it, right? So if you think about Kubernetes policies are the way they are enforced today, the difference becomes obvious, right? When the policy enforcement happens in CI, the developer pushes changes, wait for the pipeline to run, then read the logs and figure out what went wrong. So, and all that he has to repeat for every fix that he is doing, right? So even what we see is like even the fix is kind of trivial, the workflow is not. And waiting, context switching, and then rerunning these pipelines dominate the experience, developer experience. And that's where the Gardon is going to try to solve some of that problem in bringing these all these policies which happened after the fact at the time of review. So you see that the ID-based linters improve this by moving the feedback earlier, but they still operates in private context. So we are not denying the fact that a lot of tools which run on your local machine would try to solve those problems, but the point is they are all private, right? The developer sees the issues in the ID, but the reviewers does not see that. And that is very important because that means that the review still requires a mental reconstruction. And the reviewers will still have to do that mental construction to get into the context, right? Whether this is going to again pass the policies, whether the developers already fixed something, right? So whereas with Gardon, you have that structured policy feedback right in your interface when you're reviewing it. So you don't have to do a mental reconstruction of the problem. You already have that kind of feedback running in your local interface. So now, when you compare this, all this, review time enforcement, when the policy validation violations are, visible directly in the pull request, the next to the exact lines being reviewed, there is no waiting, right? You don't have to again wait for your CI pipelines and admission control to run again and then give you the results back. Oh, there is some kind of a problem. Now you have to redo again the whole cycle. So fixing these problems becomes local, immediate, and the actions. It's more actionable because you are able to see that review. You are able to see that feedback at the review time. So you'll directly fix that problem before even going into the CI/CD pipeline or admission controller. Although you run it at the local, as I said, but it's not common for all the reviewers. So the results should be consistent and should be shareable with everyone. And this difference has nothing to do with, I'm sorry. So, this difference had nothing to do with any kind of a typing speed, any kind of a raw performance. It's all about eliminating that delay, okay? So we have those tools in place, but what we are trying to do is just surfacing that back into the reviews. Okay, so yes, Gardon does have some limitations as well. As of now, the version that I have released so far, it does have some limitations, and I wanted to call it out before we get into the demo part of it. So, Gardon focuses intentionally on the validation part only, validation-only policies, although you would see that the tools like Kyverno or Open Policy Agents do a much more complex job. So right now, the focus is not on, having everything what these tools are already delivering, right? It's about trying to capture the maximum what we can do on the local machine. So those capabilities require, those kind of complex things would require, the clusters to be available. Those definitely the cluster state becomes really important over there, and the broader execution contexts are better suited for these kind of tools which are already running as a guard in the CI/CD or in the admission controllers. So the Gardon also currently supports policies that can be reduced to reduced to be deterministic, resource local predicates. So that is where we are limiting Gardon, and it's highly dynamic policy that depends on the runtime state. Obviously, those are complex scenarios, so we're not trying to solve all those right now with this tool. And all this actually allows Gardon to be, remains fast, predictable, and safe to execute entirely on the client side. And that goal is not, it's not a, kind of a replicate of full admission control, as I said. It's basically to surface those majority of common misconfigurations early and when they are, cheapest to fix. I have actually a recorded demo of this one. Just wanted to play this. Yeah, before I do that, I wanted to make sure we have the volume. Do we have the volume? This. I have the full volume over here. It's not coming up. Does it have any volume? The volume is not coming up. I mean, the sound. Because this is a recorded demo. I need to play this. Is this the one?
You can try that. Oh yeah, there we go. Okay.
Oh my God. Reduce this. Not this. Doesn't have. It's here. It's here. Is it playing?
Evolving, the core of policy validation and the rule engine logic will remain the same across all editions. Any differences will be limited to advanced or optional capabilities and not to the fundamentals. So what you're seeing today is the community edition. To use it, you will need to host your own policies before validating any Kubernetes resources. So this version is still in an early adoption phase, and at this stage my primary focus is learning from real world usage rather than fully productionalizing the community plan. The goal right now is to keep the policy management simple while ensuring that the underlying enforcement and validation mechanisms are robust, scalable, and future proof. So I would really encourage you all to try it out. GitHub issue link at the end of the session, so please feel free to report any kind of an issue, any kind of a suggestions, improvement, or any request for new features. So Gardon is totally open source, and the contribution of any kind are welcome, whether that's like a feedback, design ideas, feature suggestions, or any kind of a direct code contribution. So I'll be more than happy to welcome more community members and build this together. Now, without any further delay, let's deep dive into the demo use cases. So once the Chrome extension has been installed, you can see that over here in the list of extensions. And in front of the extension Gardon, you can see there are 3 dots. Once you click on that, you would see options. Once you click on that, it opens up a page, a new tab where it says Guard on Policy Manager. As I mentioned before, this is a community edition and you are responsible for managing all the rules. So that's where this page has been developed, where you can add all kind of rules. So we'll go over the different kind of rules that we can add. We'll see all of them one by one. So at the left top corner, you can see there are 3 buttons. The first one is to add a rule. So when I click on it, it just opens a panel where you would have to define the fields for a particular rule, starting with the rule ID. That's a string, so you can have anything over here. The next one is description. You describe about what kind of rule this is. The third one is a YAML path. So in your Kubernetes YAML, you would have different fields. So you need to specify the path to a particular field separated by a dot. And then the fourth one is a pattern where you match whether you would need a specific value in that field or a specific pattern in that field. So that is the fourth one, which is the pattern. It is in regex form. The next one is a kind, which is pretty much predominant from the Kubernetes schema. So any kind of the Kubernetes resource that you wanted to verify, which is it's a deployment or it's a pod or it's a stateful cell. The next one is a field called required, which has a Boolean value, either true or false. So I categorize the rules mostly into 2 categories. One is which would say that you need a particular value. So in that case, that required field will be true. Whereas the other rule says that a particular field value should not be there. For example, an image tag like latest is not allowed. So you would say false for that particular matching pattern. So in that sense, the required field you'll have to add it as false. And we'll see all this with an example when we import the rules. The next one is the severity. So you can define a rule as a warning, as an error, or as an info. And the next one is message. So you need to just specify a message what the user would see when the rule is triggered. It's more of explaining what kind of rule it is, what is needed. And then there is a checkbox called enable, which will allow you to enable and disable rules. So for example, you wanted to disable that rule for a time being, so you can simply click on this checkbox, disable it, or you want to keep it enabled, then just check it. The next 3 fields are text fields. The first one, which says the fix. So this is very interesting because when you have a policy violation or a validation which has failed, it becomes important to explain the user that what kind of fix needed over here. So this particular field will allow you to add a JSON structure here, and you will provide the fix directly into the validation. So that means when you open the YAML file, or when you open the fixed YAML file, it will show you the complete structure of the YAML file with the fixes. So that this particular field would make that enable. The next one is the rationale, which is again an optional field. So you can specify like why this rule exists, and referring to the site of whether it's a CIS, NIST, Kubernetes, or any kind of an internal documentation. And the third one is also a kind of a reference. So you can provide a link to any of the documentation, whether it's internal to the organization or it's a standard document. So you can pretty much do all that for the rules. So this is a high level structure of the rules. The next button next to this one is an import rules. So here I have 2 options. One is I can choose a file that has to be in a JSON format. So I can import all the rules which are specified in a JSON format. And the next one is to provide a link. So this one is particularly for the Kubernetes use case. So let's say your organization is already using Kubernetes as a policy management tool. So you have those policies and you wanted to reutilize that in Guardon. So you would just have to use the link, a GitHub link. So once you provide a GitHub link to that Kubernetes policy, it will fetch that and convert it into Guardon specific rules, and you can import it directly. So we can see those 2 things. One, importing a particular JSON file which contains rules. So I have a list of rules which are listed over here. I have this file already into the GitHub, so I can simply import it over here. And once I say import, it pretty much converts all that JSON document into my Garden specific, and I can show that on the screen. So you would see this over here as I was explaining about the particular field. So a particular rule. So you can see over here, you can click on the edit button and you will see that all the rules are listed over here. So all the fields like ID is defined as, particularly for this rule, it's required resources. The description is simple, requires CPU memory request and limits. The YAML path is specific to a deployment. So that's why it says spec template, and then under the spec you have containers and the list of, obviously list of items over there in the containers. So it's asking for resources. So if the resource is needed over there, that's what this rule is, says required. And then severity is defined as error. A simple message that will appear when the validation fails is going to be container must define both request and limits for the CPU and memory. And as I was mentioning about the fix, so you would see that a JSON kind of an fix is provided over here. So you will see that when we validate a deployment file, a deployment YAML file, and it has this kind of a violation, then how does this fix work? So we'll see that. And then simply I have, for the sake of demo purpose, I just listed a link over here to my own GitHub repository, and then again for the reference. This is just for the demo purpose. So that is what the rules look like. And similarly, as I was talking about the other option that we have over here, so I have a Kubernetes policy link over here, a GitHub link, and I have opened it in a raw format. So I copy that, and then I go to the Garden policy manager and put it over here. So when I say this refresh, it says that it fetched the content into the import area. So you can see that it is being fetched over here. And when I say import, it just gives you a preview of what exactly the Kubernetes policy has detected. So it says disallow host path and host path. So this is a simple example. So the host path volumes are forbidden. The fields spec volumes host path must be unset. So that's what the rule is saying about. So we simply import it, and now that you see that the total count of the rules has gone from 28 to 29. So this is again a kind of a utility information over here, which gives you how many total rules are there, how many of them are enabled, how many of them are disabled. And another utility beside this is you can search the rule by its ID, description, or anything. So this is to provide a flexibility in terms of searching the rules and how many total rules are there when there are more than, like, let's say more than 30 rules or more than 40 rules, and it's going into multiple pages. So it will be easy for you to search those rules. So now that we have these rules defined, let's reutilize them in validating the YAML files, the Kubernetes specific YAML files. And since I have a lot of rules which are applicable to deployment, the Kubernetes deployment object, so let's take an example of a deployment. This is a demo repository that I have under my GitHub dev org. So you can pretty much utilize the same thing. It's a very simple YAML file for deployment. And once you open this in GitHub, you can simply go on and click guard on extension, and it will give you this pop-up which will give all kind of violations according to those rules. So you can see over here there are 16 violations, out of which there are 9 errors, 5 warnings, and 2 are enforced. And then it also says that there's a schema-based validation, but ultimately there is no matching schema. That means the YAML itself, the guard on does not understand the schema. So because we haven't uploaded any Kubernetes specific schema file. So far it says 16 violations, and if you can take any of these examples, like let's say required resources. So it says the container must define both request and limits for CPU and memory. So that rule, that is not applicable over here because the resources are not defined. So that means this is a violation and this is defined as an error. So now if you click on this one, this icon which says preview patch, so it will give you a detail of like how this YAML file should ultimately look like when the resources are added. So you can pretty much copy that YAML file, or if you wanted to download it, you can download it and then finally just close it. The other icons that I have over here are basically directly you wanted to just copy the snippet, the code snippet over there, or if you want a little more information about why this violation, then as I was describing about defining those rules, you can have those boxes where you can define kind of an explanation that you wanted to put for this validation. So that is there, the 3 action buttons that we have for all the rules. If it is not there, like for example, the information I'm missing, so you won't see that icon. But for most of the rules, you will see this 2 icons. Some of them may not have it because we haven't defined those code snippet in YAML format, in JSON format. The other utility that you simply have here is just copy the complete report. You can copy it, or if you wanted to take a different look and feel of this pop-up, then you can change the theme. That's a simple button over here. And if you see total 16 violation, and we don't have any schema over here. So now what we'll do is we'll go ahead and upload a schema file. So if you see, look at over here, there are 3 buttons over here, out of which the first one is the import Kubernetes API. So once we click on that, it gives us an option to select a file. Again, I'm going to select one of the files that I already have in my demo repository. So this is an OpenAPI spec for Kubernetes version. And I do have 2 fields over here which tags this particular OpenAPI schema with a particular cluster. So I can say it's a prod cluster or dev cluster, and I can define it as a particular version. And then just say save. Once it saves, I can see there are 2 entries which are pretty much similar. This is because I have a duplicate entry in my file, so I'll just remove one for the sake. And then when I go back again in validating this YAML file, I simply click on this icon once again, and it again gives 16 violations, but this time it doesn't say the schema is missing, but says that the type mismatch for the specific replica's expected integer but got string. So you see that the replica over here is defined as a string. In case of the OpenAPI schema, it has to be an integer. So that's why the rule fails and it lists over here. Now so far we have seen that when we invoke guard-on on any of the GitHub pages, it automatically fetches that YAML file and validate against it. But let's say if you wanted to, if somebody invokes the guard-on extension on the page, which doesn't, it's not a GitHub page or doesn't have a YAML file, then it would say that no Kubernetes YAML is detected on this page. But it does give an option where you can paste the YAML file and validate it. So let's say we validate the same YAML file in a non-GitHub page. The result should be same. Yeah, so it still says like 16 violations, 9 errors, 5 warnings, and 2 info. So it's pretty much the same thing. So that's an option. If you don't have the YAML file or a GitHub page, you can still copy paste the YAML file and do all the validation. That's an option. The next example is custom resource definition, so which is very much common in Kubernetes. We create custom resources. For example, this one. This is a YAML file for kind database, and this YAML does have a problem, but guard-on as of now doesn't understand this YAML schema. So if we try to validate this, let's see what does it say. So I'll invoke guard-on on this. So it says the schema validation, so no matching schema found. So which is right? There is no schema. So on the guard-on policy manager, I do have a button at the bottom which says import custom resource definition. I click on that and I would choose a file. This is again going to be from my GitHub resources. So I do have a schema file for this, and when I upload it, it get uploaded, it says CRD saved. And then I go to this one and now try to invoke guard-on. It says that the schema was found, the schema validation, a type mismatch for spec version expected string got number. So the version over here has to be a string, but instead of that, it's an integer. That's why it does report that. So that's another functionality or capability with Guardon that you can upload the custom resource definition schema files and then validate against it. All right, the last part of the demo is to use open policies. So companies are adopting to open policy agents because it gives them a consistent, scalable way to manage policies across increasingly complex and distributed systems. Open policy agents lets policies separate from implementation, which improves governance and reduces operational risk. And to support this, I have made use of Open Policy Agent WebAssembly module. So the WebAssembly, or WASM, is a low-level binary format that lets you run high-performance code safely inside the browser or other runtimes. So the first step is to have your policies written in Rego format and then compile it into a binary, which is compatible to run on a browser, or basically it's a .vsm file. So I have a README file which explains everything about the Rego policies and how do you compile the Rego policies into a WASM format, which is a .vsm format. I do have support here for the Windows. I haven't added it for Mac. I'll have to do that. But you'll find all the examples and how to compile it, how to extract it, and rest of things. So you can go through this one. For the sake of the demo, I do have already compiled policy, already a .vsm file ready for you. So let's take a look to that. So on the Guardon Policy Manager page, you can see those three buttons at the bottom. The last one is to import the OPA rules. So when I click on that, it gives me an option to upload a file. And when I click on it, it again gives me an option to upload a .vsm file. I do have it compiled in my demo repository, so you can pick it up from there. And before I do that, I also wanted to show you that the Rego file that I have over here, which is this one, it has somewhat 4 rules, which is pretty much similar to what we had in the Guardon simple rules. So it's related to deployment. All of them are related to deployment. Like the container is missing the CPU request, it's missing the memory request. Those simple rules are there in this Rego file. I have compiled that into a .vsm file. So now when you try to upload that over here, so once I click on save, you will see that it appears over here. Now what Guardon does, it stores the byte locally and loads them via a small Open Policy Agent VASM runtime, which is an OPA WASM bundle.js. So when you validate YAML, we'll see that how it works. So let's go back to our repository and just pick up the same sample, which is our invalid deployment.yaml. And then I again click on Guardon. So now you can see instead of 16, I have 17 violations. So I go all the way down, and here you will see that my Open Policy Agent has kicked in. The policies are getting executed on the browser itself. So what it does is when you validate a YAML, Guardon turns the document into a JSON, passes it as an OPA's input, runs the VSM policies entirely in the browser. So there is no network calls. And then merge any decisions or violations returned by the OPA into a small, in the same result table as Guardon builds in. And then you can see that those are all the results over here. So yeah, that's it for this demo. Thank you for watching.
Yep, I mean, that was the demo on version 0.5 that I've built so far. There are some, kind of an enterprise concerns I can highlight. Like, at this point, just wanted to explicitly acknowledge a concern that comes immediately in enterprise discussions, right? So, in the current version, the Guardon, as an individual user, you can still go ahead and install it. It's available on the Chrome Web Store. But obviously, for the enterprise version, which I'll be working on, would require more control because if you try to install it if you're in any organization, you're trying to install it, it won't allow it, right? So, and this is not a flaw. It's basically, it's deliberately basically about bootstrapping the choices, and not intended at that state. So the purpose of the current model is to just validate the core hypothesis, the review time, review visible enforcements, and meaningfully improve feedback latency and remediation behavior. And on top of that, I mean, obviously, we are looking at AI and the agents, AI agents, which will be doing a lot of reviews in future. So there is again a difference on a lot of things where if you look at any regulated industries, right, they won't just have these AI agents making decisions. The existing policy engines like Keynote or open policy agents would still play a crucial role in having the decisions, making those decisions as an important factor. So the agentic AI could be one of the governance layer, which would act as more of a suggestive, right? Because they are good at doing the prediction part of it, right? So I see that in long run it could be a layered governance, I can say, where at the top layer you can have AI providing all kind of probabilities and feedbacks. I see Guardon can still be leveraged by AI agents because Guardon is actually leveraging those existing tools which play a very crucial role in governance. So all the policies that exist using these tools, we are just bringing that to the review time enforcement, and the agent can still depend on this to produce those results, to give some suggestions. As I was showing in the demo, that there are, when on a particular failure or a review failure or a policy violations, you have 3 buttons, which gives you a feedback, right? What kind of fix can be applied on top of it. So similarly, those feedbacks comes from those policy engines, and that can be leveraged by the agentic AIs to surface it back as a proper feedback, give you more reasoning about it. So yep, that's pretty much it. I'll just open it for any question and answers.
Okay. Is it possible for other team, other companies to get this tool and get their own policies and use your tool? What's the input for to prepare the policy to import to your tool? Is that JSON or YAML format policy file?
I didn't get the question completely. You mean like?
If, for example, if our hospital wanted to use your plugin, and how we can use it, how we prepare the data, the policy to use your tool.
So okay, so this is basically right now it's an extension, a Chrome extension. You can simply download it. But as I mentioned in right now in this version, the community version, you'll have to build your own policies, right? But in case of enterprise version, there could be policies which are already existing. So in that case, you might have to have either preloaded or cache those policies in your browsers. So it may be that you might have those policies pulled into your GitHub repository, loaded them into your local machine. But yeah, that could be for the enterprise version. For the community version, you will have to still write your own rules.
Okay, so suppose we have our policy in PDF files or Word document. Do you have a tool to convert, to prepare the input for your tool to import?
Yeah, you'll have to prepare that because right now the tool accepts any JSON format, right? So you'll have to convert that into JSON format to fetch it and upload it.
Okay. Do you have some AR tool to do this kind of automatic conversion from the
But those policies have to be, it has to be technically sound for the tool to understand it, right? Right now the policies it supports is Keynote, which is cloud native policy engine. So any kind of those policies, either in YAML or JSON format, which is technically correct and relevant for the Kubernetes, that can be imported. So you'll have to, whatever policies you'll have, it has to be specific to Kubernetes.
Okay, yeah, because we have thousands of policy documents in hospital.
Thank you.
Okay. Well, thank you very much.
Thank
and
you, everyone.
that concludes SCaLE for 2026. See you next year.
Thank you.